hotter and hotter and hotter. Oh. And then you get this thing here, which it could either shatter or it could break. And that was given to me by a guy who was using it for solar observing, and he was using a 4.5-inch reflector at full aperture. So, yeah, these things can happen. Oh. So, yeah, you can, and the one thing I mentioned is that these solar filters are actually coming up again on websites on the internet, where you can buy them on the internet, and they come with, and they're quite prolific. So yeah, be mindful of the fact that if you do use these, they can be quite.
Usually up and down.
Up and down. Okay, yeah, sure. Oh. So before solar observing, read the instructions thoroughly about whatever equipment you may have. Heed any warnings. If you can, if you're a beginner and you've just got your telescope, join a society, if you're not a member of a society, and learn from an experienced solar observer. If in doubt, don't take chances with your eyesight or anything else like that. And no responsibility will be taken by me or for any act or omission or anything else like that, because I'm irresponsible. Now, this is one of my finished observations, because now I rarely look through a telescope when I'm doing solar observing. I image a lot. I don't use the sophisticated stuff that you can buy nowadays, like the ZWO cameras and things. I use a DSLR camera, a Canon 600D that I got cheap from a second-hand shop. And it gives some very, very good views. As you can see on this one, my observation shows basically everything you need to know about how to take this picture. Basically what type of refractor and all that sort of thing. The date, what the weather's like, everything. This is obviously the 17th of April 24th, but I'm hoping later on, if I've got enough time, I'll be able to show you what's been happening, observing last year. Now, obviously, each day, the sun, because the sun rotates, it rotates once every 27 days, so it will change every day by 13.2 degrees. So obviously, the reason I like the sun is because it is dynamic. It just shows you a great deal of stuff. And it's moving, and sometimes you don't get that many sunspots, but other times you can get a great load of sunspots. And in the early days, this used to be a real pain, because when you're projecting the image onto a piece of white card or anything else like that to do the observations, we had to draw it. We didn't have cameras that did what they do nowadays. We just had pencils, 3H pencils and things like that. And we used to draw these things, and something like that would take me about an hour to do before I could actually walk away. But yeah, you can see that's, we got the rotation. As you can see here, the sunspots will be changing, and that's a nice big sunspot group. Now, the idea is, the sunspots you can see, you have a small spot there, which has got the dark area, which we call the umbra, and then we've got the outer lighter area, the penumbra. These are magnetic situations on the sun. I'm not going to go into that, because basically that's a talk by itself. But it was one thing I can say. There was a guy in the 1800s called Heinrich Schwabe. Heinrich Schwabe was basically, he wasn't an astronomer to start with, but he was very interested in looking at the sun, not for sunspots, but for looking for the planet Vulcan, which was supposed to be a planet which was between Mercury and the sun. Now, he watched the sun for 20 years, noting everything that went down. He didn't find Vulcan, but he did discover what we call the solar cycle, which was you notice that the sunspots basically came to zero and then went to a great deal of sunspots, and then it went down again. But I might add that the solar cycle is only an average. It works out about, they say it's 11.2 years for a solar cycle, but in all my dealings, on my observations, I found out that some cycles have been elongated with not a lot of activity, and others have been very high activity but very short in duration. So it's only an average, and each cycle may vary in the amount of activity and length of the cycle. And sometimes you get what you call the busy sun. You get a lot of sunspots, and at other times you get nothing. You might get a few. Here you can see a couple of little sunspots there. Perhaps another couple. Oh, a bipolar group there. 2 sunspots there. And that may happen for months, maybe years on end. So it's a very easy time for solar observing. However, it's worthy of note. Now, what telescope or instrument should I use? Well, we've got various amounts of telescopes. We've got refractors, reflectors, Schmidt-Cassegrain, Maksutov, other types of telescopes around. I use this. As I say, this is for using for projection, and as you can see, that was my setup that I have with a nice projection box that I made. This projection box isn't one you buy at a shop. I made it for about the equivalent of $7, and that's basically 2 pieces of 3mm ply and 4 dowels, and that's it. There's your projection box. You could put a hole in so you can put it onto the telescope where the eyepiece holds, and you can see the sun quite well projected in that going back into my past again, 1985, we used to have the Japanese refractors. I know the older guys here might think you have might recollect these. This was one called the Prince Astral telescope, and it had literally everything. The box it came in had the solar projection screen, Barlow lens, eyepieces, everything you wanted. You didn't really need anything else, and that cost at that time about £400 in 1985. On the other hand, you had the little smaller, cheaper telescopes like the Tasco, which were you could get, which were on altazimuth mounts. Either mount is either good for doing solar observing. It doesn't really matter, except the equatorial is better because you only have to move one axis. But with the altazimuth, it's a little bit up and a little bit around and all that sort of thing. But when I was a director, I used to get a lot of kids sending observations in just using these small altazimuth refractors. This was a telescope that I got in Australia when I went over there a couple of years ago. Celestial Astronomy, it was a sort of a shop where they, people, they send all their trash and they send it to the, get these big dumpsters and they come and pick it up. They have a shop there where they get all the good stuff and try to resell it. And I managed to get this Celestial Astromaster for 75 Australian dollars. It was about $60 to buy, and that was for the whole kit and caboodle. But the idea is, again, we had to be careful because it had a metal tube but a plastic focusing mount, and so I had to. I found I couldn't use it for projection, so as you can see there, I made a little bit of a filter at the top. I'll come to that, and I use it for taking pictures. For enclosed telescopes, compound telescopes like Schmidt-Cassegrains or Maksutov Cassegrains, you only use objective filters. You don't use it for projection. The heat buildup inside the telescope may damage the components, and yeah, I wouldn't use anything. Normal reflectors, Newtonian reflectors, can be used, but care is needed. And here you can see this is an LX10 that I used to have, and that has a full aperture solar filter on the top of it. You can buy them fairly easily. But this one uses Astro solar film, and as you can see, it was very, it enclosed the whole of it, so you could either look at it or take photographs through it. It's very, very good. And by the way, solar film, Astro solar film, comes into two qualities. One is a grade 3 and a grade 5. The ones we normally use for visual work is grade 5. Grade 3 is one you use maybe with a different type of filter called calcium K, but it's one which lets more how you say, harmful stuff through. It attenuates not as much as the grade 5, and of course you don't use it. So you have to be very careful on that, what type of solar film you get. Again, I'll go into that later on. Now, when you're using a reflector, normally you see there you have a cap. You get them on all telescopes, and normally if it's a reflector you have a off-axis aperture there. It's about 40 millimeters in diameter, and this one was for a Russian TAL reflector, which used to be a big, very, very sturdy metal telescope. The idea is, I must say as well, if you do buy a telescope, you want it for solar observing. If you can get one which is all metal, great. That's obviously going to be better for you. But as I say, if you've got anything with plastic in it, you want to leave it alone. Don't just, you can use it for solar, but you have to use it with filters. And if you use the solar apertures on refractors, here you can see it prevents too much light and heat entering the telescope. But don't look through the telescope, even stop down. This is only for projection. Now, here's another telescope that my son bought me, bless him, while I was in Australia. They say it was a short focus reflector, and here you can see this cost about $70, 70 Australian dollars, about 55 American dollars. You can see there's a nice sort of telescope. It wasn't that good a telescope, unfortunately, but I did still be able to do some work with it. And that's another thing. When you have a telescope, it doesn't really matter what the telescope looks like. As long as you get a good image, who cares, you know? But this one I used, but he did have a little bit of a mistake with it. Oh, they're going back. Please spot the deliberate mistake. This cap, the solar filter, the solar aperture was right in the middle, and everything is stopped by the spider or the secondary holder. So you couldn't actually see anything at all. So you have to be careful on that. But you can see here, I used a bit of the old makeshift cardboard off-axis, and there I made another sort of solar projection screen, and I can see everything. Solar finders, finding the sun. How do you point your telescope at the sun? Well, the easiest way is just by pointing to the telescope, looking at the ground, and getting the smallest configuration of the tube on the ground. And that's good for reflectors and refractors. But you can buy, sort of solar finders like this. This is one I managed to get fairly cheaply from an online shop, and it works very well indeed. You can get other ones. This one was for an ETX, which basically caps the finder scope and uses the this little pinhole. But the one thing I want to say is, when you look at the sun, you don't want to look up towards where it is. You want to look down away from it, because obviously you don't want to look at the sun at all. So as you see, everything that I'm showing you is where you look down away from the sun. And another one which was around was this one, which went on the ETX 90 telescope, and basically it's a little gnomon in the middle, and that allows you to point the telescope in the right direction. So there you are. You've got basically what a telescope looks like. But the other thing is, when you look at the telescope, and it's the solar projection boxes at the bottom end of the telescope, it's a good way to have it. But if you're using a short focus, and you may have to use a Barlow lens to get a reasonable image, using this configuration will upset how the sun looks. North and south and east and west may be in different positions, so you've got to be careful on that. You can read these in books and everything else. I mentioned about Japanese eyepieces in the past, and the ones we use now, which are one of the quarter eyepieces. Here you can see on this one, this is a 0.96 eyepiece that I was using. So I did the projection there, and I wanted a quarter, and you can see there's not much difference in how the aspect of the sun appears on the projection screen. They all are pretty good. So, but the only trouble is now 0.96 eyepieces, a lot of them are just plastic. They're plastic eyepieces. You would not use them for projection. They would be damaged. So, you know, the basic setup that I have at home is like this. It's just a telescope, and this is the early version that I have. It has an EQ2 mount, and it has a drive on it, which helps greatly. It has this solar projection box, so everybody, if you want, can have a look. It's very easy to see. You just need to focus it. You sometimes get very good views of the solar surface. And Trevor, I got signing in on another device on this. Sorry. And what happened was, I take this around, and sometimes when we've got, you know, solar eclipses, partial eclipses, the neighbours come round and come and have a look because they want to have a see it. And it's a nice thing for, you know, showing other people. And the idea is it stops people, you know, children getting their heads near to the eyepiece or anything else like that. You just tell them around, please don't put your hand in it near to the eyepiece, or it could be, you might get a bit of a shock. And in England, I did this on for another talk I did in England, and as you can see, the difference in aspects of the sun, depending where you are in latitude. I'm at 53 degrees latitude in England. Here you see, in May, I've got you know, the sun is way above there, but in December, you can see, it's pretty difficult because then the sun is very low down. You've got interference, not only with clouds at low level, but you've got roofs, television aerials, everything else that can get in the way of observing. The other thing is for projection is simple eyepieces. And this is where, believe it or not, people used to say these eyepieces weren't very good at the time. Especially in the 80s, 70s and 80s. And this is due to the fact that they were made from very simple components. They were, the eyepieces we have today have lenses which are cemented together quite a lot. If you use these eyepieces for solar projection, you still get heat there because it's near the focus of the telescope. And if it's not very good, this the cement in between can basically be destroyed, overheated, and it separates the elements. And so if you're using something like a radian for projection, I wouldn't. But normally these ones, the very cheap eyepieces, Huygens, Mitzenway, Huygens and Ramsden's have all uncemented elements in them. So therefore the likelihood of damage is negated a bit. So these are the best eyepieces, but nowadays, the most I would ever use for projection would be a Kellner, because that has a cemented eyepiece at the top and a sort of a uncemented filled lens. But the idea is it's how you want to do it. Normally, I use a cheap eyepiece to project the sun on. So there we have it. We have our, you can see there's my solar projection box. I've had that for nearly 20 years now. And the idea is to stop other people putting things in, and to increase the contrast of the image. I've put paper all the way, black paper all the way around it, and you can see I'm getting a nice view of the sun. Here we have the image of the sun, which we call the photosphere, and it's on here you will see all the activity going on. And to show you what it's like, here we have the photosphere, and we have a nice big sunspot. Very nice, actually, when you think about it. You get a good view. And if you see the, if it's going straight down onto the projection box without being tilted in any other way, west is normally the direction of image travel, east, north, and then south. But as I say, orientation may differ with what you use, other equipment that you use. Binoculars. I always turn around and say, well, I try not to use binoculars if I can. They can be used for projection, but because they have a lower magnification, you need a longer length of throw to get a decent image. And then you have to cap off one side, otherwise you get the image in stereo. But again, it's one of those things, it's very easy for people just to, oh, hello. Oh. It's very easy to people just to come up and, oh, let's have a look, and all that sort of thing. Being on a tripod would be better, but if you did use this for solar, I would not leave it unattended. And then again, the components on the inside may be damaged if they've got any plastic parts in there. You just don't want to use it at all. Okay. No.
Sorry.
How's it going so far? Yeah, everybody, okay, that's good. I have to have a quality check every so often, you know what I mean? So, no, it's just me. You don't want to look at me.
I think we've lost the connection to the thing. It's having problems connecting on my machine.
Anyway, going on from this, so yeah, when you have your setup, you've got your projection box there. You're looking at the sun. You see these. You see the photosphere, and basically what we try and say is, if you do have a projection box, try and get an image around about 6 inches in diameter. That is the normal sort of setup we used to use for drawing and things like that. And then we had, and on there you will see the sunspots quite easily, but obviously it's a matter of tracking. The sun moves, if you try to use a higher power, the image actually moves quicker. Moves quicker across, and actually you try and, oh, sorry. Yeah. It moves very quickly, and so trying to get any detail or anything can be quite difficult. Yes, please.
This is for visual observation. Okay.
Yeah, visual observation. Yeah.
So if I get a projection on one of these, I'm going to pull out my sketch pad.
Yeah, well, I'm going to, if I can get back up on this, I was going to go into that and how we did it in the past. You can still use it today. This is what I'm saying. Projection is good, and you can still observe using the techniques that I did. But, other people have ideas. I know that people still draw sunspots. Even professionals draw sunspots on their telescope using their...
Take a picture with the camera of the projection?
Yeah.
There you go.
I've done that as well, yeah. And normally, when I started taking pictures, using I used a Kodak, with the little the first ever Kodak digital cameras. And I had to put it up at the far end of the projection box, if I can get this on here. Oh, go on. And then snap a picture, and I used to get some really good images of the projected image. So that was, and I used to use that a lot in the for the reports I did to the society I was a director of. Now, the other thing you can use, obviously, if you want to go a little bit more visual, they used to have these things, and they're called Herschel wedges. Now, this was a solar diagonal. It was, this is a Japanese model from the 1970s. I've never used it to, and 10 minutes.
Well, 10, 15 minutes.
Okay, right. But now you don't have these. You have this thing made by Lunt or other manufacturers, which are a safe way to look. And a lot of people use these Herschel wedges. You don't need a solar filter at the top end, but the idea is you still need a bit of careful, and people use this type of equipment for imaging with cameras. Anyway, so yeah, projection is a little safer version of looking at the sun. Oh, hello, we're gone again. Little bit safer, and it can give very good images of the solar, and it allows groups of people to have a look as well. So I've done that in the past.
For some reason, the Skype keeps on dropping out, and I don't know why.
No. Anyway, carrying on. Yeah, sure. Yep, sure. Well, basically, it is like a star diagonal. As you know, a star diagonal has a mirror, and it normally gets the image. from the objective, hits the mirror, and then bounces it up at 90 degrees, and it goes into the eyepiece. It's principally the same idea, but the idea is it has a wedge-shaped, clear wedge-shaped piece of glass. And what happens is the image goes to this wedge-shaped piece of glass, goes through either an aperture at the rear end. Most of the light and heat goes through the aperture at the rear end, as you saw with that Japanese model, and about 5% of it goes up into the eyepiece, which can be dimmed down by a neutral density filter, I believe. I think that's the way they do it. And that's okay for using, maybe for the eye or anything. It's safe for the eye to look at. But the
reflects 95% of the light out of the...
Yeah, it takes an awful lot of the light and heat out, and it makes it safer. However, I've never done that. And particularly with that Japanese model, because although they were, you know, sort of, they had these solar filters as well, and I didn't trust the way they did solar work, did solar equipment at the time. So basically, I just stay with projection. But yeah, it was I've just got it there.
No, we're just trying, we haven't
Yeah,
with the...
but what I used to do, basically, I'm going to go into it because I've only got a few minutes left, is that I got a sheet of paper which had a graticule on it, and I made another sheet, the same graticule on like a board, so I could put a piece of paper on there, and by plotting where a sunspot is on this graph on the projection box, I could transpose it onto the same sort of thing I had on my board, and I used to draw the sunspots that way, and that gave accurate plotting, basically. And then I used to use the sunspot counting sheets, which allowed me to count the number of sunspots each day over a given period, normally a month. And at the end of the month, I would count it up, a little bit of calculation, and all it is a bit of sort of counting up and then dividing its averages, and you get a number which we call the mean daily frequency. This mean daily frequency is a number, so you plot that for that month, it was 6, you know, maybe 6 one month, might be 7 the next month, 6.5 month after. So you keep doing that over the year, and perhaps longer. I have been doing it, and it's something I was going to show you, but unfortunately maybe...
No, we'll get back up.
Okay. And then you've got the R numbers, or the Wolf numbers. That's done by a different sort of calculation, and the idea is by using the two, you can make a graph up which shows you how the sun has been active over a given period. What I've tried to do since I've been retired is take pictures every day of the sun, or observe the sun, take reading, you know, see what sunspots are on there since pictures since 1922, but I've been taking sunspot counts much before then, and I've been trying to get a graph of the activity over the present course of cycle 25, which is what we're in at the present moment. The system, so at the present moment, we had a nice spike last year, a couple of years ago, of activity. The averages have been somewhere in the region of about 6 to 7 to 8. Then it went to about 9 point something or other, and then it's come back down a bit. A lot of people have been turning around and saying that the solar cycle has peaked, but in observations I've had done in the past, I think it's cycle 23, if I'm not mistaken, which happened around about 1989 to 1991, that was a very active system cycle, because we had two peaks, one at the start, had a little bit of a lull, then another peak, and each time we had quite a lot of auroral activity occur, which was recorded.
It's getting there.
Oh, good. And then obviously we got, then obviously what I've been trying to do is take these pictures, and what I showed some people when they first came in was all the pictures on the PowerPoint presentation, so showing the rotation and what sunspots were going out there, at the time. What I'm going to do when I finally get, I'm going to have to cut out a bit of this and go to the recent activity, which I think you'll be more interested in. So I've shown you how to look at the sun using your telescopes, giving you the warnings, how you record, and basically what I'm trying to do now is, what I want to do is show you what's happened over this past year. And there's been a lot of activity, which is unfortunate, I can't show you, but it's been very active. And I've been noticing that there's a roundabout in the southern area of the southern hemisphere of the sun, there has been one particularly spatial point where there has been a lot of activity, and sunspots have been, very big sunspot groups have been growing there. And I've been noticing also that sunspot groups have been coalescing, they've been coming together. You have outlying sunspots which seem to be drawn into this one particular place. I've also got some hydrogen alpha. I want to go a little bit into hydrogen alpha. I can't do that now, obviously, but it's showed you another aspect of beginning solar observing you can do, because hydrogen alpha telescopes, in my day, you just got the filter and you had to build a telescope, which had very, very long focal lengths. And fortunately now you can get other hydrogen alpha systems, which is looking at in a different light, and basically you're looking at a higher part of the sun, the chromosphere. And in here you see things like the prominences, flares, if you get them, plages. It's a different look at the sun, but it's all nowadays being used. And I know a lot of people have got hydrogen alpha equipment, which is very sophisticated. And like Trevor here, he puts results of some of the pictures he puts on, and they're absolutely fantastic. I have a PST, a personal solar telescope, costs about £800 in the UK, and it was. I also utilise that as and when I can. The PST, Coronado PST, was not meant really for imaging, but the idea is I learned that if you use a imager such as the Astrocam that you use for guiding, which has the imager right at the front of the camera itself, and you put it down into the focusing mount of a PST, you can actually achieve a focus there and try and get some images if you can. I was going to show you that later on. But basically, roundabouts, I think I'll stop here, Trev, now.
Okay.
What I'll do is I'll say, who remembers May the 10th, 2024? Yeah, that's when we had the aurora. I had the aurora in Skegness. And that was due to a flare which occurred on the 9th, I think the 8th or 7th or 8th of May on a sunspot group, which I had, and I had it in hydrogen alpha as well. And it gave us a fantastic show of the northern lights. I know when I looked on the internet and on Facebook in particular, a lot of people, I think from here, were there with their hands in the air going way with the northern lights in the background. You know. At the present moment, that is it really, put it into a nutshell. But the one thing I want to turn around and say is heed the warnings of looking at the sun. Don't do anything which will endanger your eyesight or anything else like that, because especially children are impetuous, and it's and if you're a beginner, just read about it in books. Come to a society, learn from other people, because that's what societies are for. You get, as far as I'm concerned, a
John, if
society.
there's any slide which you want to show.
Oh, right, okay. Have you come up? No.
Yeah, you are.
Ah. Right. Okay, thank you. I've come this way. No, that's coming down. Excuse me. here, if I can just get these in quickly. If
Let me just go up there.
I'll just go up there a bit.
Just a second.
Yeah.
Give me a few seconds.
Yeah. These are the ones I wanted to try and show you. 2024 going into March, April, and into May. This one in particular was very interesting in the fact that at the time I was able to see a flare using the PST. And it's these things, it's just by chance you get to see these things. It's unless you're there constantly observing, it's only a chance meeting that sometimes you can get to look at these things. But you see, normally I've been finding out over that past year, round about this latitude, there's always been a sunspot group or a lot of activity round about that time. It's now actually gone into the north a bit over this current year. But around, during 2024 and coming into 2025, this latitude was an awful lot of activity round about here. And yet in the north, it was relatively clear of sunspots.
And it's not doing anything. It's going to be one of those days or years or months or whatever.
Yeah. But I think you can just about see here, there's a little dot there, you can see where the, what's the name was. And then what I was going to go into was, can I do it?
Yeah.
Oh yeah, here you see around April, I'm just, this is to end. These are my observations are done now. I do it via a camera. I have a DSLR camera on the front, and so I can actually take pictures using a solar filter on the top of the telescope. And they're very easy to do. This is done, all the information is there. It's done at prime focus, so there's nothing, no eyepieces between the telescope and the camera. It's just basically using the telescope as a telephoto lens. And you can see here, but if you have a look on this, these, here we have the systems developing, and you see NOAA have different numbers for various sunspots. But a lot of them are coalescing together to become one big active area. This is a montage of the of AR3664, which gave that May the 10th the solar flare or CME that happened, that gave us that wonderful aurora. And as you can see there, we had how it developed in the east, came round again at that same latitude, round about there. And as I say, round about the 7th and 8th, we had this solar flare. Just there, this is what I got on my hydrogen alpha. Very active region, nice prominences there. And there's the aurora in Skegness, where I saw it. Not as good as you, judging by what I saw on the pictures that you had on Facebook. But yeah, I was quite happy. But getting to the end now, if you really don't want to do anything, I said this is limited technology. There's this wonderful telescope now called the Sea-Star. And I know for a fact that in England, these things fell off the shelves as soon as they were put up. Because these are apochromatic telescopes. It's basically robotic. That's what I call it, a robotic telescope. And it outputs to phone and other portable electronics, iPads or whatever. And basically, you get good views. It's non-visual, so you're not looking down it. You're just using it on your iPad and seeing the information there. And to give you an idea, that was yesterday's look at the sun. And this is today. And if you notice that between the two, this is using the Sea-Star solar filter. And that is one that's made by First Line Optics in the UK. And it uses beta astro solar film. And I bought this for Trevor as a present. It's first work today, hasn't it? So, but yeah, we've got a nice big sunspot there, and that gives you this today image. And for those people who were really getting worried about the fact that I'm not doing anything about deep sky, there you are. That is by using that Sea-Star. Yeah, that's the Sea-Star stuff. So I've given you deep sky people a chance to say, oh, thank God for that. So yeah, before solar observing, read how to observe the sun how to observe safely on astronomy websites and literature. coming here, learning from other people. Be mindful of the warnings, looking at the sun either through the eye, with the eyes or looking through optical equipment. So I will go, any questions there? Sorry, I couldn't show you everything, but it was, I could perhaps go back if you got on questions. Yeah, go ahead, please.
Can you address these Daystar quark hydrogen alpha eyepieces that are about 1,000? And how they compare to a dedicated?
A lot of people do buy them, but and at the present moment, I don't know too much about the quarks, because the one, if I can just zoom back up, there's my PST, show you what the PST looks like. There's a Daystar Solar Scout, which I used to have. This was, the quarks and things were basically a quark with a telescope on the end of it. And you see, you still needed a power supply, because the Etalon here, this thing called an Etalon, here needed, has a little oven inside, which was actually activated by a wire, and you turn that knob every time you wanted to sort of tune the telescope. You have to tune these things by either tilting the Etalon to get the right bandwidth, and so you can see the detail. You had to wait 10 minutes each time you turned that knob before you looked at the eyepiece again and then saw the image of what you got. And then if you got it wrong, you had to turn it again and wait another 10 minutes. So in the end, I ended up buying one of them. And all you had to do was turn a little ring here, which allowed you to tune the system. But unfortunately, this one here, this type of telescope, only doesn't do a sort of a full aperture hydrogen alpha image. It has what they call a sweet spot, and you can see the sweet spot every time you tune it. You see this sweet spot going up and down, and that's where you have to do it. So really, this one was meant for visual, looking through visual only. But as I say, other hydrogen alphas that they have now, like the Lunts and things like that, especially more the higher end, are, you can see, like Trevor's got, you see some of his stuff is really, really good. But
We have another question.
oh yeah, sorry, yeah.
Does it make any difference which side of the sun you're looking at?
Well, we can only see one side of the sun.
The sun rotates.
Yeah, because it rotates. Because the idea, going back, have I got any more time, Trevor? I'm not going to impinge.
Maybe another 3 minutes.
2 minutes, okay, right. If I can just find the bit.
One thing why John is doing this, unfortunately, we've had a lot of problems with Zoom and projection. So,
by the way,
John is going to do the talk again at Bryce, but also at the Utah Valley Astronomical Club at the middle of next month. So I'm going to ask if we can actually do a Zoom recording of that meeting, and then we'll broadcast that and let everybody know that they can actually watch this again on Zoom and get it properly recorded. Yeah.
So yeah, you got this is what I observed, groups, the sunspots and things like that, and the little ones are pores. We have bright areas near the edges, which we call faculae, but basically, you mentioned about solar continuum filters. I've got a little one here which shows the 8th of January, both white light and solar continuum filter. I found this not particularly, didn't really enhance it too well, but...
I think we actually have another question.
Yeah, sure, go ahead.
I've got a double stack on my PST that I've had for a couple of weeks.
Yeah, that's the double stack there, yeah.
And it seemed like it was a lot darker. It was harder to get the image.
Yeah. The early ones, the early Daystars used to be just an instrument you put on your telescope, and you had an energy rejection filter at the top, and they were very dark. You could hardly see them looking through them. You really need to have good eyesight. But yeah, it did get a bit dark because you got two Etalons going through two Etalons, and it does attenuate the light coming in quite a lot. I found that on this. This is why I use basically an electronic eyepiece for this. It's like a camera you use for a guiding eyepiece, like a ZWO
Oh,
One,
like
two,
a 174 or something.
122, I think it's a 122 that I use for that, or it's an Altair Astro cam. That's I use that, and that's what gives me the that gives you the visual representation like that. It's not very good, but at least it gives you some idea of what I can get.
I think Les had a question.
Yeah.
Did you? Oh, no, I was.
All right.
Oh, okay, so David.
When you're projecting, which I've done everything on
Yeah.
project, I did that when I was a kid. But can you actually see the faculi?
Yes, you can. You can see faculi on projection quite easily. When I say, when you look at the image on the projected image of the sun, if you normally look on the outside, because of it's going through more solar atmosphere, the edges are more attenuated in the light. So you see these little sort of white areas, if I can just pull one down.
You just see it on the edge. So,
Yeah.
so what about can you actually see, probably not granulation, but how much of the detail on the spots can you actually
Now, this is one I want to show you. This is what I took last year in Salt Lake City. Here, you've got a little bit of faculi coming off here. This is the faculi. You can just see it streaming off.
No, I understand, but how much of that can you actually see on the projection?
You can see, you should be able to see quite a lot.
Even on the inside.
Yeah.
What about the detail on that spot? Can you actually see how much detail in the penumbra can you see?
You can see quite a lot. Yeah. And even if you change your eyepieces when you're projecting and you enlarge the image, you can see even more, but not even towards the center. It depends on the sunspot, obviously. If there's more activity, you get around the edges, you can get more faculi, more brighter faculi. And sometimes you can see here, if you have a look at here, there's some faculi just around that area, just at the top. Yeah, and you can see that on projection, no problem. Or you shouldn't have any problem.
Okay, sorry, one last question.
Yeah.
When you're projecting, you can go through like, sometimes you see going through a bar roll or something like a negative rather than doing the eyepiece.
Yeah.
Also, years ago I saw someone using, there was an article that I think they suggested just using a flat, really make like an up-pinhole projection. I mean, instead of a pinhole, you could throw it a long way to get an image like the eclipse.
Yeah. I mean, when this one here, as you see, this is a short focus refractor. Stop down, using the aperture, but it has a Barlow lens down here, so it expands it to, doubles it. So instead of a sort of like a 500, you have a 1,000mm telescope, and that would give you the image there like that, if that's what you're referring to. Yeah, the idea is unfortunately, most of the stuff nowadays is achromatic. So the chances are you're going to have to use a lens which you might have to turn around and say, well, I don't use this all that much, or it's cheap, you get a cheaper version, and then try and use that for solar projection. Because the only trouble is, nowadays, eyepieces and equipment in general is much more higher standard.
Okay, so I'd like to say thank you to John for the presentation. And John will be coming to the advanced training afterwards if anybody has any questions. He'll also be here for a month, so if anybody wants to contact me with additional questions, he'll be at the solar party and various places. Yes.
May I ask a quick question?
Yeah, sure.
Somebody, Sue Sedona,
Yeah.
she wants to know where you got the shield for the personal solar telescope.
Oh, right, yeah. Now, I got that from a British maker. I think he used to be called Astro Engineering. I don't know if they're around now, but I do believe they still make them. You have to hunt through the internet to find it. But yeah, that particular one, if I can quickly just go down, Trevor.
Yep.
Oh, by the way, that's my graph of all cycle 25. You can see from April 2021, 5 years worth. And that's the observing I used to do. Let's go and have a look. Let's see, you get the... There, that's it. That's what you're looking at, yeah. And it was, I've still got it at home now, and it's very useful. You can put your eyepieces on it, and the actual fact, it stops people when they look at there, looking up like that and looking directly at the sun. So it really is a very, very good idea. Yeah.
Okay, so again, thank you, John, for your speak.
Thank you. And thank you for inviting me anyway. Thank you very much.
Again, John will be at Bryce and at UVAC.
Yeah. And the idea is, while I'm there, if anybody's got any questions or needs help with their equipment while I'm there, I'm only too happy to help with them. And it'd be nice to meet other people. And actually, I want to meet other people with these wonderful, new, big, expensive Lunt hydrogen alphas as well. I don't, there must be a few of them around. But I'd like to learn about that as well, because I don't get much exposure to those big instruments. So I'd like to have a look at that.
Okay, thank you very much. And now I'll go back to the next part. Hopefully this is all working well. Okay, so where were we? Okay, so the next thing which I'd like to do is a couple of the business of the society. And for some reason it's still not expanding. Oh well, we'll just have to go down. It's going to be one of those days. It's always one of those days. First of all, at the last board meeting, we confirmed a new board member at large. His name is Brad Dea, if I get that correct. I apologise if I didn't. And his responsibility will be coordinating the volunteers for the star parties at the Stansfield Observatory Complex Night Sky Star Parties. The financial report, let's see if I can blow this up at all. Nothing is working. Okay. Now this is... It's like my machine is actually frozen on me. So, next. This is so weird. Everything is going wrong on this machine. It's like the mouse is not working there. You're just being mean now. Okay, here we go. Okay, we are back. So, at the last board meeting, there was a nomination for the Lifetime Achievement Award, and we are very happy to confirm that Marlene Edgar was given the Lifetime Achievement for her services in the Star Party training and other work which she's done with the Society over the last couple of years. We have a whole suite of other people nominated, which will be at the next board meeting and then also probably confirmed at the next general meeting. But first of all, I'd like to congratulate Marlene for this award. And again, if you have any nominations, please send them to board@slas.us. The next, I'd like to do some special thanks and recognition. First of all, Ken, who is sitting at the back, we launched the new website. I know there are a few little glitches in it, but those are rapidly being fixed by Ken and the team working behind him. But I really want to congratulate Ken for all the years he's put in, 20 plus years of work on the existing or the old site, and then really leading and spearheading the development of the new site. So, Ken, thank you so much. Also, at the last Star Party, we had some special booths set up. And the first one was, there's a gentleman called Benjamin Stevens, a younger member of the club, very informed gentleman. He knows pretty much everything about everything. And he actually was standing near an observing information booth. And so now, when people have questions about astronomical events going on or general questions, they can go to him and he will be more than happy to give them a very in-depth dialogue on their particular question. So thanks to him. The other is Krista and Jeanette Scott. Jeanette Scott's sitting down front. And they had another booth on the Night Sky Network. And that proved very popular. I had many people coming up and saying, this was an excellent new addition to the star parties. So I really want to thank all of them for their work in terms of additional outreach and information being provided. As I say, I had a lot of people really saying that they enjoyed it and wanted to see it often. And also, Krista was at the last solar party as well and did the same type of desk. Though it's very, very windy out there, blowing everything off. Leslie Fowler and Jeanette Scott re-silvered the Clements, so special thanks to them. That's quite some work, I believe. And then also Jim Keane and Luke Moses for their work on the SIG scope and the Spock maintenance. So they're the people who really make sure the star parties are successful. We can still use the telescopes, and so really a lot of thanks to them. And then of course everybody else who has really contributed and helped maintain the facilities and the star parties. Without that, we couldn't do a lot of the outreach which we do. So as it's a half-year mark, halfway through my term, so to speak, I really wanted to acknowledge and recognize everybody who's contributing in our journey of outreach. So the new website, this is what it looks like. So when you go to slas.us, you'll now see this website. If you do see any issues on the website, then please let the board know, again, board@sls.us, or Ken, if you know his details directly, webmaster down below, you've got all the details there. Please let them know. We've got a list of items which we're working through to correct, but I'm very pleased and happy that this is now up and running, and a lot of kudos. The next item is a notice, and at this point, I am the one who's actually proposing the change. So, as it says down below here, I am actually recusing myself because I don't want there to be any potential conflict of interest, personal integrity type issues being perceived. So I only feel it's fair that I recuse myself for any further discussions on this one. And I'm going to hand it over to Jeanette, who's going to give you details on it.
All right. Good evening, SLAS members and SLAS board. Thank you for being here tonight. I'd like to take a few minutes to explain an important matter now before the membership regarding proposed amendments to the SLAS Constitution. SLAS is first and foremost a member-led organization as outlined in our Constitution. In accordance with Article 8, any member may submit constitutional amendments to be considered by the membership. These proposals do not require board approval. In this case, SLAS member Trevor Hebditch has submitted a set of proposed amendments, 4 amendments. Because Trevor is also the current president of SLAS, and in the interest of fairness and transparency, he has fully recused himself from the amendment process. As vice president and in line with Article 4, Section C.2.a, I, Jeanette Scott, have stepped in to facilitate the process. I want to emphasize that I am acting in a neutral, impartial capacity. I am not advocating for or against any of the 4 amendments. My role is to ensure that our process remains fair, transparent, and member-driven. In accordance with both the SLAS Constitution and Robert's Rules of Order, this is what will happen next. Tonight is simply an introduction to the amendments. The discussion will take place at the July General Meeting, which is Wednesday, July 16th, 2025 at 7:30 p.m. Between now and then, members are encouraged to submit their thoughts, pros and cons in writing by July 30th. Please do not tell me your opinion verbally. They must be submitted in writing via email to be officially considered. Those written omissions will be published anonymously in a special edition of the NOVA newsletter on August 1st to ensure all members can view the perspectives of others without fear of harassment or retaliation. Rules for the July 16th discussion. Each member may speak up to 3 minutes per amendment. While a member has the floor, they may not be interrupted. No member may speak more than 2 times per amendment. After 3 minutes, the member must yield the floor. Disruptive behavior or personal attacks will not be tolerated. Robert's Rules Section 61 allows the chair to call any disorderly members to order. Upon the 3rd offense, the assembly may vote to remove the member from the proceedings. There will be an election committee formation. An election committee will be formed to assist with any voting or tabulation needs relating to these amendments. This committee will consist of 3 SLAS members who are not on the board, be selected from a pool of volunteers who have not taken public position on the proposed amendments, be chosen at random to ensure fairness and neutrality. If you are interested in volunteering and are not publicly for or against any of the amendments, please reach out to me. How to review the amendments. You can review the full text of the SLAS Constitution, the proposed amendments, and a side-by-side comparison chart in the July-August 2025 NOVA newsletter, which is posted on the website. To get there, visit slas.us, log in to your account, click on the Education tab, choose NOVA, open the July-August 2025 issue, and refer to pages 8 through 14. Please take the time to read the documents carefully and respectfully. Come to the July meeting ready to share your perspective with courtesy and clarity. I'll read the proposed changes. Do we have time for it? Oh, you have it. They're up here, so I don't have to read them, which is good. But I'll do a summary. So, summary of proposed changes to the SLAS Constitution. Change number 1, board term limits and re-election exception. The current rule, no member may serve on the board more than 2 out of 3 consecutive years. Proposed change allows a 3rd consecutive year if another non-related board member proposes the extension at the August board meeting. The board supports it and announces the motion at the August general meeting. 4 additional non-related members supporting it in writing. Then the person can run again following normal election procedures. The purpose adds flexibility or continuity in leadership if a strong candidate wishes to continue. Change number 2, associate membership. New category, non-voting associate member or for educators providing STEM/astronomy programs. Dues, none, but must pay SPOC fees. Benefits, access to newsletter and SLAS Blast, no voting rights. Eligibility, approved professionals, teachers in educational institutions. Purpose, encourages outreach of educational collaboration without diluting voting control. Change number 3, honorary membership. New category, honorary members for longstanding members, 10+ years, would be the longstanding, awarded by the board. Dues, none unless voting rights are desired. Benefits, all regular privileges minus voting unless dues are paid. Purpose, honors commitment while preserving the member-funded model and optional voting. Change number 4, membership dues clarification. Current wording, all members pay the same dues. Proposed update, regular members pay dues, associate and honorary members are exempt unless voting. Purpose, aligns financial rules with new membership category. Alrighty. SLAS is a place where curiosity, respect, and collaboration shine, so let's keep it that way. Thank you for your time and your commitment to this great organization, and I look forward to collecting and hearing your views.
Thank you. as I've mentioned, as I've said, I am recusing myself from any of this, so we'll just do, don't give feedback to me, please give feedback through Jeanette or through the approved process, and then we'll have the discussion and do the voting in accordance to the Constitution and rules of the Society and Robert's Rules. Okay, next week we have AstroCon. So I look forward to seeing all people going down there, and I hope we have a great time, because apart from maybe some fire or smoke issues which are currently going on, I look forward to a great event with some excellent speakers, including two of our own, Martin Ratcliffe and John Smith, who's visiting. That's really excellent, so looking forward to that one a lot. Okay, so some other business. I was very happy when Patrick Wiggins brought to our attention that a long-standing member, Michael Herban, actually has published a book. It's not on astronomy, but it's sort of an interesting book anyhow, The Physics of Birding. And if you're interested, you can go to this site and download or order a download copy. I'm not sure which one it is, but also he has said he's going to donate a copy to SLAS and give away at the December meeting. So I just want to recognize that and really say thanks both to Michael and also to Patrick for bringing it to our attention. Reminder, please sign up to become an operator assistant at Spock Star parties. You'll see emails coming out from Brad on this. I think another one's coming out tonight. Oh, you already sent it, thanks. So yes, please sign up. It's a great opportunity for people to learn how to use the equipment at Spock. You don't need to be a trained operator to be an assistant. So to me, it's a fantastic way to start using the equipment and getting familiar with it. The next talk, which we were due to have, is now going to be postponed to allow for the constitutional discussion. So that will be the next meeting. Beyond that, any other comments, thoughts or concerns from the membership at this time? Yes.
Big thing here, anybody who wants to go to AstroCon that has not registered, you can register at the meeting. It's $100 per person, cash only at the time, but you're responsible for all your room, your meals, and you cannot buy t-shirts. So yeah, we will take reservation at the desk there, but it'll be cash only. There's an ATM right across the way.
Okay, so just to confirm what was being said there, you can go to AstroCon and register down at AstroCon for $100 cash. Cash means cash. Okay, and if you do that, you won't be able to buy any of the t-shirts or other materials. Also, you would be responsible for all your own food, but it would allow you to actually partake of the other events and items going there. So please, if you want to, you still can go down there and do that. Yes?
Could you tell me more about what advanced training means?
Certainly. Next item. So advanced training is basically we go to Dee's restaurant, we have a meal together, and over that meal we'll discuss a variety of topics of interest to whoever is attending. A lot of them is astronomy related, some of them are not. So it's just a get together and
It's a social.
social, yes. We just call it advanced training.
And they're scheduled when?
Immediately after this meeting. When we leave here, we then go to Dee's, so you can see where we are. I got the pointer. So we're here, and you just go out down the road, and Dee's restaurant is here.
Did I hear someone say SLAS pays?
Okay, on that note, I want to apologize for all the hiccups which we've had. I will try and broadcast this talk at the UVAC. I can't guarantee it'll work, but we'll do our best. We'll make an announcement.
What we can do, if you wish, we will do it at your home or somewhere else, and I will do the talk on you record it, then you can put it on the website.
Oh yeah, we can do that as well. We'll work out something. You're here for a month, so I'm going to find some way to get you to do it. With that, I'd like to wrap up this edition of, or this meeting, and thanks everybody for coming and being so patient. Have a good evening. Thank you so much for your help.